What if a black hole existed that defied every known law? Imagine scientists discovering something that rewrites physics completely overnight. This is not fiction, but a mystery shaking modern science today. Deep in space, something strange refuses to behave normally at all. Astronomers noticed signals that made absolutely no logical sense initially. Light bent in unexpected ways, contradicting everything we once believed. Gravity acted strangely, almost like it had a mind itself. The object seemed powerful, yet oddly inconsistent in behavior patterns. It didn't follow traditional models of black holes at all. Scientists were confused, curious, and slightly terrified by this discovery. What kind of object ignores the fundamental laws of physics completely? The answers began emerging slowly, each one more shocking than before. This black hole seemed to break rules that define reality itself. Even time appeared distorted differently compared to typical black holes. Something deeper and far more mysterious was clearly happening here. Experts started questioning whether our understanding of space was incomplete. Could this discovery change everything we know about the universe today? The data kept coming, each reading stranger than the last one. Patterns didn't match any known celestial object ever recorded before. It was like watching reality glitch in real time through telescopes. The scientific community quickly became obsessed with solving this strange puzzle. Theories clashed as researchers debated what this object truly was. Some believed it was a new kind of black hole entirely. Others thought it might reveal hidden dimensions we cannot normally see. The tension grew as more unexpected results kept appearing daily. Every answer seemed to create even deeper and harder questions. Something was clearly wrong with our current understanding of physics. This wasn't just another discovery, it was something far bigger. It challenged the foundation of theories built over centuries of study. Even the most experienced scientists felt unsure about their conclusions now. Could this be evidence of unknown forces shaping the universe secretly? Or perhaps something even stranger beyond our imagination entirely exists? The object's behavior suggested something completely new was at play. It wasn't just bending light, it was distorting expectations themselves. Data showed irregular emissions that made no measurable sense whatsoever. Energy levels fluctuated in patterns no model could properly explain. This raised a terrifying possibility about our understanding of reality. What if the universe operates under rules we haven't discovered yet? The idea alone sent chills through the scientific community worldwide. Observatories focused intensely on capturing every detail of this anomaly. Each observation revealed more inconsistencies that deepened the mystery further. It felt like chasing something that didn't want to be understood. Some scientists even questioned if their instruments were malfunctioning completely, but repeated tests confirmed the readings were indeed accurate always. That meant the impossible was actually happening right before us. A black hole that simply refused to follow expected behavior patterns. The implications of this discovery could change science forever completely. It might even redefine how we understand space and time itself. The curiosity surrounding this object grew stronger with every observation. What if a black hole existed that defied every known law? This wasn't just about one object, it was about everything. The universe suddenly felt more mysterious than ever before imagined. And with mystery comes both excitement and deep uncertainty simultaneously. What secrets could this strange black hole possibly be hiding? The deeper researchers looked, the stranger things continued becoming gradually. It was like uncovering a puzzle with missing essential pieces. Each clue hinted at something far beyond current scientific knowledge. The pressure to understand it grew stronger every single day. Could this discovery unlock hidden truths about the cosmos entirely? Or would it only create more confusion than clarity eventually? The journey to understand had only just begun at this point, and already it was more complex than anyone expected originally. One thing was certain: nothing would ever feel the same. The universe had revealed something it wasn't ready to explain yet, and this was only the beginning of an unbelievable cosmic mystery. Scientists quickly began analyzing data using the most advanced tools available. Observatories around the world focused intensely on this unusual cosmic object. The first step was comparing it with known black hole behavior patterns. Surprisingly, nothing matched even slightly with existing theoretical models. Traditional black holes follow predictable rules based on strong gravity, but this one behaved differently in almost every measurable way. Its gravitational pull fluctuated instead of remaining consistently powerful. That alone confused researchers who expected stable and predictable forces. Light around it didn't just bend, it twisted unpredictably. This created visual distortions, unlike anything previously recorded in space. Scientists initially suspected errors in instruments or data collection systems. However, repeated observations confirmed the strange behavior remained consistent. This meant the anomaly was real, not a measurement mistake. The discovery pushed experts to revisit fundamental physics concepts entirely. Could gravity itself behave differently under extreme unknown conditions? That question sparked intense debates across global scientific communities immediately. Some researchers proposed the presence of unknown exotic matter nearby. Others suggested interactions with unseen cosmic forces affecting its behavior. The idea of dark matter influence became a serious possibility, yet even that explanation failed to fully explain the observations. Another theory suggested a rotating structure, unlike typical spinning black holes. But the rotation patterns didn't match any known equations either. The deeper scientists investigated, the more complex the mystery became. It felt like trying to solve a puzzle, constantly changing shape. Energy emissions from the object also showed highly irregular bursts. These bursts appeared without any predictable timing or measurable pattern. Normally, such emissions follow known physical processes and energy laws. But here, those laws seemed completely unreliable and inconsistent. This raised a bold idea about unknown dimensions influencing this object. Could hidden dimensions be affecting how matter behaves near it? The concept sounded extreme, yet nothing else fully explained the data. Some experts even explored possibilities involving advanced cosmic phenomena interactions. Theories stretched beyond traditional science into new and unexplored territory. Every explanation opened new questions instead of providing clear answers. Researchers started building new models to simulate this strange behavior. These models attempted to recreate the unusual gravitational fluctuations observed. Yet simulations often failed to match real-world observation results accurately. This suggested something fundamentally missing from current scientific understanding. It wasn't just about this object, it exposed deeper gaps. Gaps in knowledge about how the universe truly operates at extremes. The scientific community became more determined to uncover the truth. New experiments and observations were planned using advanced technologies worldwide. Space-based telescopes were adjusted to monitor the anomaly continuously. Every second of data became valuable in solving this mystery. The object's unpredictability made it both fascinating and deeply frustrating. Scientists needed answers, but the universe refused to cooperate easily. Each discovery felt like progress, yet also created new confusion. It became clear this wasn't a simple phenomenon to explain. Something entirely new was challenging everything we thought we understood. The pressure to find answers grew stronger, with global attention increasing. Media coverage added excitement, while increasing expectations for quick conclusions. But science rarely provides immediate answers to complex mysteries like this. Researchers knew patience was essential, despite growing curiosity everywhere. The anomaly demanded time, effort, and entirely new ways of thinking. It forced scientists to question long-standing assumptions about space behavior. Even the most trusted equations seemed incomplete in this situation. That realization marked a turning point in modern scientific exploration. It showed how much we still don't understand about reality. The black hole became a symbol of the universe's hidden secrets. And those secrets were far more complex than imagined before. Scientists realized they were standing at the edge of discovery, a discovery that could reshape everything humanity knows about existence. But first, they had to face the uncomfortable unknown ahead, because understanding this object meant rewriting the rules entirely, and the next discoveries would become even. As research deepened, scientists uncovered patterns that seemed almost impossible. The black hole appeared to release energy in reverse sequences sometimes. This strange effect hinted at unusual behavior involving time itself. Normally, time moves forward consistently across all known physical systems. But here, observations suggested something bending time in unexpected ways. Signals seemed to arrive before the events that created them. This caused confusion and excitement across the entire scientific community. Could this object somehow interact with time differently than expected? The idea sounded impossible, yet data strongly supported this phenomenon. Experts revisited theories about space-time under extreme gravitational pressure conditions. Some theories predicted unusual distortions near highly massive cosmic objects, but nothing ever suggested effects this extreme or unpredictable before. It was like watching cause and effect lose their normal order. That alone challenged one of the most basic principles of physics. The principle that effects always follow their causes in sequence. If this rule breaks, reality itself becomes difficult to define. Scientists carefully examined whether delays or distortions caused this illusion. However, calculations showed the signals were genuinely out of sequence. This forced researchers to explore ideas once considered purely theoretical. Concepts like time loops and warped timelines became serious discussion topics. The black holes seemed to blur the line between past and future. This behavior suggested something far deeper than simple gravitational effects. It hinted at the possibility of unknown structures within space-time itself. Structures that might influence how time flows in certain conditions. Some scientists propose the existence of temporal distortions or anomalies. Others explored ideas involving quantum-level interactions affecting large-scale objects. The connection between quantum physics and gravity became more important. This object might be bridging two fields not fully unified yet. That possibility alone made the discovery incredibly valuable for science. It offered a rare chance to observe new physics in action. Observations continued, revealing even stranger patterns in emitted signals. Some signals repeated in ways that defied natural explanation completely. It was almost like echoes from events that hadn't happened yet. This raised questions about information traveling in unexpected directions. Could information move backward through time under certain conditions? The idea seemed extreme but could not be ignored anymore. Scientists worked carefully to avoid jumping to unrealistic conclusions quickly. They relied on data, calculations, and careful peer review processes. Even so, the mystery grew deeper with each passing observation. Every new dataset added more complexity to the unfolding situation. It became clear that simple explanations would never solve this puzzle. A completely new framework might be required to understand it. That meant rewriting key parts of physics as we know it. Such a change would impact everything from space travel to technology. The implications extended far beyond this single mysterious object. It could change how we understand time, energy, and existence. This realization brought both excitement and cautious concern to experts. Discoveries like this can reshape science, but require careful interpretation. The scientific method remained the guiding principle throughout this process. Hypotheses were tested repeatedly before being considered even partially valid. Collaboration increased as global experts shared ideas and research findings. The mystery became a collective effort across countries and institutions. Everyone wanted to understand what this black hole truly represented. Was it an exception or part of a larger hidden pattern? That question became central to ongoing investigations and discussions worldwide. If more objects like this exist, everything changes dramatically. The universe might be far stranger than we ever imagined before. And this black hole could be the first clue, a clue pointing toward deeper truths about reality itself. The journey toward understanding was becoming more intense and complex, yet scientists remained committed despite the growing uncertainty ahead, because answers to mysteries like this can change human history. The black hole continued to challenge every assumption made so far, and its secrets were far from being fully uncovered yet. The next phase of discovery would push science even further. As exploration continued, the black hole revealed even darker mysteries. Scientists detected strange patterns that resembled structured information signals. This suggested something inside might not be completely random at all. Black holes were once thought to destroy all incoming information completely. However, these signals hinted that information might survive somehow. That idea directly challenged the long-standing information loss paradox. If true, it would overturn decades of established theoretical physics. Researchers carefully rechecked all instruments to rule out contamination errors. Yet the patterns remained consistent across multiple independent observatories. This consistency made the discovery increasingly difficult to dismiss. The signals appeared encoded in complex and repeating mathematical structures. It almost looked like something was transmitting hidden messages outward. Scientists debated whether this was natural or artificially structured behavior. Some considered exotic quantum effects producing organized emission patterns. Others cautiously suggested unknown cosmic mechanisms beyond current theories. The possibility of encoded information inside a black hole shocked experts. Normally, nothing escapes a black hole once it crosses the boundary, but these signals appeared to originate near the event horizon. That region became the focus of intense scientific investigation worldwide. Advanced simulations attempted to recreate event horizon conditions precisely. However, even the best models failed to match observed patterns. This failure indicated missing physics in current scientific understanding. Researchers began exploring quantum gravity as a possible explanation. Quantum gravity attempts to unify gravity with quantum mechanics principles. Yet even this field struggled to fully explain the anomaly. The black hole seemed to operate beyond known scientific frameworks. It acted like a natural experiment testing the limits of physics. Each new observation challenged assumptions made in previous research. Scientists realized they were dealing with something truly unprecedented. The object's behavior suggested hidden layers of reality beneath space. These layers might influence how matter and energy interact universally. Some theories proposed that spacetime itself could be fundamentally discrete. If true, this would reshape our understanding of continuous space. The black hole might be exposing these hidden structural properties. Observations also showed sudden collapses and re-expansions of energy fields. These fluctuations defied every known model of gravitational stability. Even supercomputers struggled to simulate such unpredictable behavior. Scientists increased observation frequency to capture finer details continuously. Each dataset revealed new anomalies never seen in cosmic studies. The mystery deepened as contradictions accumulated in every analysis. Some researchers suggested the object might not be a true black hole. Instead, it could be an entirely different cosmic phenomenon, perhaps a transitional object between known and unknown cosmic states. That idea opened new possibilities for astronomical classification systems. It also challenged how we categorize celestial bodies in general. The universe might contain objects beyond our current naming systems. This realization humbled even the most confident scientific experts. Years of knowledge suddenly felt incomplete and insufficient. Yet curiosity pushed researchers to continue despite uncertainty. International collaborations expanded to include more advanced research facilities. Space agencies prioritized this anomaly above many other projects. The urgency to understand it grew stronger with each discovery. Public interest also increased as information slowly became available. People around the world began following updates with fascination. The black hole became a symbol of scientific mystery and wonder. It reminded humanity how little we truly understand about space. Every answer uncovered seemed to create even deeper questions ahead. Scientists knew they were approaching something fundamentally important, but the full truth still remained hidden beyond their reach. The object continued behaving in ways no model could predict. Each observation felt like a step closer to revelation, yet the final explanation still remained frustratingly out of sight. The universe was clearly protecting its deepest secrets carefully, and this black hole guarded them more fiercely than expected. The final breakthrough was still waiting somewhere beyond discovery. After years of study, a breakthrough finally began to emerge. Scientists noticed a hidden consistency inside the chaotic black hole data. Beneath randomness, there appeared a repeating universal mathematical structure. This structure suggested a deeper order governing extreme cosmic phenomena. Researchers carefully mapped every signal to decode its hidden meaning. Slowly, patterns started aligning with revised quantum gravity predictions. This gave hope that a unified explanation might finally exist. The black hole was not breaking laws, but revealing hidden ones. It behaved like a natural amplifier of unknown physical principles. Scientists realized they had been interpreting data too narrowly before. Once assumptions were removed, clarity began to slowly take shape. The strange time distortions matched advanced space-time curvature models closely. Information signals aligned with theoretical holographic universe principles. This hinted that reality might store information on cosmic boundaries. The event horizon acted like a complex informational encoding surface. Instead of destroying data, it may transform it fundamentally. That discovery reshaped understanding of black hole mechanics completely. Energy fluctuations also matched predicted quantum vacuum interactions precisely. This confirmed that quantum effects played a major role here. The object was not breaking physics but extending its boundaries. Scientists began rewriting models to include these extreme conditions. New equations successfully simulated earlier observed anomalies accurately. For the first time, predictions matched real observational data closely. This validation marked a historic moment in astrophysics research. The mystery gradually shifted from confusion to structured understanding. Yet many questions still remained unanswered about its origin. No one knew how this black hole first formed uniquely. Its formation process might involve unknown cosmic evolution stages. Some suggested collisions of exotic high-dimensional energy structures. Others proposed remnants from early universe quantum fluctuations. Each theory opened new paths for future scientific exploration. The black hole became a gateway to deeper universal truths. It inspired new generations of scientists and researchers worldwide. Space agencies planned missions to study similar anomalies closely. Advanced telescopes were designed for higher precision observations soon. Humanity realized the universe still holds countless hidden secrets. Curiosity became the driving force behind future cosmic exploration. The discovery reshaped textbooks and scientific understanding globally. What once seemed impossible became a foundation for new science. The black hole's mystery evolved into a lesson about humility. It showed that knowledge is always expanding and incomplete. Scientists learned to embrace uncertainty as part of discovery. The universe proved far more complex than earlier assumptions. Every answer uncovered led to even deeper mysteries ahead. Yet progress continued steadily through collaboration and innovation. The black hole remained a symbol of unexplored cosmic wonder. Its behavior still hinted at secrets beyond current understanding, but humanity now had a clearer path toward truth. The journey transformed science into something even more powerful. It united curiosity, technology, and imagination in one pursuit. In the end, the rules were not broken, but expanded. The universe revealed itself as stranger and richer than expected, and the black hole became proof of endless discovery potential. Scientists continued watching, knowing more surprises could still appear. the story of this anomaly was far from finished yet. Each new observation promised another layer of hidden reality. Humanity stood at the edge of a new scientific era, one defined by mysteries that challenge imagination and logic alike. The black hole changed how we see the cosmos forever. And it all began with something that broke all expectations. The universe is still speaking. We are only learning listening. Future discoveries may reveal even greater cosmic revelations ahead. Science continues evolving as we push beyond known boundaries. The final truth may still be waiting in deep space, and the mystery of this black hole lives on eternally.